Hey everyone, welcome. Today, we're going to go on an incredible journey through the very fabric of reality itself. We're going to explore the fundamental framework of our universe, dimensions. So let's just dive right in. I want to start with a question. I know, it sounds like something straight out of a sci-fi movie, right? But this question is actually at the very heart of modern physics. It really challenges everything we think we know and asks us to look beyond what's right in front of our faces. This is the big idea we're going to unpack today. So, to even begin to wrap our heads around that, we're going to do something really cool. We're going to start from absolute zero. We are going to build our reality from the ground up, adding one dimension at a time just to see how it all fits together. Okay, so first things first. What even is a dimension? Well, the simplest way to think about it is as a direction you can move in, or a coordinate you'd need to pinpoint a location. It's basically any way you can measure something. And when you put them all together, they create the blueprint for all of existence. Our journey starts with the absolute simplest universe you can possibly imagine, the first dimension. So the key thing to get here is that in 1D, you can only go in two directions, forward and backward. That's it. There's no up, no down, no left, no right. It's just pure, simple length. Now, of course, we can't see a truly one-dimensional object, but we use the idea all the time. Just picture a train on a perfectly straight track. You only need one number to know exactly where it is. This simple line, well, it's the building block for everything else. All right, you with me? Let's add another coordinate and build on our line to create the second dimension. So you take that first line, length, and you add a second one at a right angle, width. And bam, you get a flat surface, a plane. Now you can move forward and back, and left and right. You've just created a world full of shapes, but it's a world that's as thin as a shadow. You know, we're surrounded by 2D all the time. The screen you're looking at this very second, it's a two-dimensional surface. A map is just our 3D world squished flat so we can figure out how to get around. It's an amazing way to represent a much more complicated reality. And now we finally arrive home. The third dimension. You add just one more direction, up and down, or a depth, and boom, suddenly our flat world has volume. Things aren't just shapes anymore, they're solid objects that actually take up space. This is our world, the world we know, defined by three coordinates, x, y, and z. I mean, this is our native habitat. Every single thing you can touch, every room you can walk through, it all exists in these three dimensions. It's so natural to us, we don't even think about it. But our journey is far from over. Okay, this is where things get really wild. And it's all thanks to this guy, Albert Einstein, who just completely flipped our understanding of the universe on its head. He realized that our three dimensions of space are actually woven together with a fourth one, time. They're not separate things, they're a single, four-dimensional fabric. And this explains gravity in the coolest way. See, gravity isn't some mysterious force pulling things. It's much simpler. Huge objects, like the sun, literally bend and dent that four-dimensional fabric of space-time. So the Earth isn't being pulled by the sun, it's just rolling along the curve that the sun creates, kind of like a marble spiraling down a funnel. So here's the bottom line. To pinpoint any event anywhere in the universe, you absolutely need four pieces of information. Three tell you where it is, length, width, depth, and that fourth one tells you when it happens. You just can't have one without the other. Okay, so we've built the world that we can see and touch. But now we're going to venture into territory that is purely theoretical. How in the world do we even begin to imagine dimensions that are beyond the four we experience every day? Well, the secret lies in using an analogy. Imagine for a second a universe that's just a flat sheet of paper called flatland. And it's inhabited by 2D shapes like squares and circles. Now, what would happen if a 3D object, like a sphere, a ball, passed through their world? Well, they wouldn't see a sphere. They'd see a dot appear out of thin air. Then that dot would grow into a circle, then the circle would shrink back down to a dot, and then just vanish. They could never ever perceive the whole object at once. And this is where it gets really mind-bending. That whole flatland story forces us to ask a really uncomfortable question. What if we're the flatlanders? What if there are higher dimensional things passing through our reality all the time, and we only see them as weird, fleeting events or forces that we can't quite explain? So, if there are more dimensions, how many are we talking about? Five? Six? Well, some of the most advanced theories in all of physics land on a very specific, kind of shocking number: 11. Now, they didn't just pull this number out of the hat. In ideas like M theory, the universe's most fundamental building blocks, electrons, photons, aren't little dots. They're actually tiny, vibrating strings of energy. And for the mass to work, those strings need more room to vibrate. These extra dimensions are curled up so incredibly small we can't see them, and each unique vibration gives us a different particle. It's an attempt at a theory of everything. And when you look at it like this, you can really see how our thinking has just exploded over time. For thousands of years, we were perfectly happy with three simple dimensions. Then Einstein comes along and blows our minds with a fourth. And now, for the past few decades, the smartest people on the planet have been seriously exploring realities with 10 or 11 dimensions. It's an incredible expansion of our cosmic viewpoint. But look, this all might sound like crazy abstract physics, but the way we think about dimensions actually shows up in our world all the time. We're literally manipulating 3D space with printers and VR headsets. Artists like MC Escher completely mess with our perception of dimensions. Scientists are modeling complex molecules in 3D, and even data analysts talk about finding patterns in high-dimensional spaces. It's everywhere. When you really step back and look at it, this whole quest, from a single, simple line to the wild complexity of M theory, it's all about one thing: trying to decode the fundamental blueprint of the universe. We're trying to understand the very structure that holds everything together. And that leaves us with one last, kind of huge question to chew on. Every single step we've taken on this journey has shown us a reality that's way more complex than we ever thought. So what else is out there, right in front of us, that we just don't have the senses to see?